Happy Independent Learning Day. Excuse me, my voice is a little scratchy today, so hopefully you can hear this just fine. These notes for today are going to be in your packet. They're the sheet that we skipped over yesterday in class. That's where you will find them. 2 examples today. Please take notes on them. We will check your notes on Wednesday as your assignment for watching this video. Just a couple other things to note. Your test is going to be on vectors and navigation on the 20th, which is 2 Tuesdays from now. Your homework packet and the 2 formatives, the green 4.8 formative and the to be determined color on the formative that you're going to take on the 14th of March will also be collected on that day. So let's dive into it. So let's say I got a soccer ball. And on one hand, I come over and I apply a force to that soccer ball, meaning I kick the soccer ball. But at the same time, somebody else comes and kicks it from the red arrow. Now, depending upon which of those kicks are more powerful is going to depend upon which way the ball travels. If my kick, the blue kick, was more powerful, then the ball is going to go in that direction. If the kicks are equal and they're coming from there, the ball would go in that direction. And if the red arrow is more forceful, then the ball is going to go in that direction. Okay? So with that being said, let's talk about multiple forces and how we figure out which direction that ball then would travel. So example number 1 says, a force of 50 pounds acts on an object at an angle of 45 degrees. Well, let's call that vector U. It would have a magnitude, because magnitude is the force in terms of poundage, so it had a magnitude of 50 pounds, and it would have a direction of 45 degrees. So if that's the case, 50 cosine, 45 degrees, 50 sine, 45 degrees. Which would give me cosine at 45 degrees is root 2 over 2 times 50, 25 square root of 2. Same for the sine. Then, my second force is 75 pounds now, so that's a little bit more forceful, but it's coming in at an angle of negative 60 degrees. So let's call that vector V. So that one would be 75 cosine of negative 60 degrees, 75 sine of negative 60 degrees. Negative 60 degrees is also 5 pi over 3 or 300 degrees. So the cosine at 300 degrees is 1/2. So that would be 75 over 2. And the sine is going to be negative root 3 over 2. So that's going to be negative 75 times the square root of 3 over 2. Now, I left those exact because we are going to have to do something with them, so I don't want to round them just yet. So if I need to find what's happening to my object, then I'm going to add these vectors together. So I'm basically finding the vector u plus v. (25) times the square root of 2 is 35.5. 75 divided by 2 is 37.5. Negative 75 square roots of 3 divided by 2 is negative 64.2. Add those together, and we get our resulting vector of so there's our resulting vector. Now from that, we can find our magnitude and direction, or so, what did it say? Direction and magnitude, yep, of the resultant force. So the magnitude of u plus v is going to be square the horizontal component, square the vertical component, and then take the square root of that. So the magnitude is going to be 78.64 pounds. And because it was labeled as pounds, that's going to be our label on our answer. Then we can find our reference angle. Gives me excuse me, a reference angle. Reference angle of 22.11 degrees. Now this vector, u plus v, has a positive horizontal and a negative vertical, which means that that vector, or this, is the 22.11 degrees right there. Which means it's a 1/4 angle, which means that actual theta is going to be 360 degrees minus 22.11. Which gives me my direction of 337.89 degrees. Multiple forces, very simply put, you just add all of the different vectors going on in them. That gives you your resulting vector. That then you find the magnitude of, which either gets you the force, pounds, the speed, if you will, miles per hour, kilometers per hour, etc., and then the direction angle of it. No matter how many forces you have, this works. So if I have 3 forces now, I would just have to do three different vector calculations. So vector u is going to have a magnitude of 70 pounds and a direction angle of negative 30 degrees. Vector v would have a magnitude of 40 and a direction of 45. All right, let's go vector w. Would have 60 and 135. So there's the vectors. Now we just have to add them. So now we're going to come up with vector u plus vector v plus vector w. And we're going to add them together. When I add up the three horizontal components, I get 46.4796, more the merrier here. And when I add up the verticals, I get 35.7107. I have them stored on my calculator as their exacts, which makes it easier. So then now we have to come up with the magnitude of u plus v plus w. So that's going to be 46.4796 squared plus 35.71. We'll just start over. 35.7107 squared. Big square root thereof. Gives me magnitude of 58.61 pounds. Gives me a direction angle of 37.5354. This vector is in quadrant number 1, so that is my direction angle. Those notes will be checked Wednesday in class. You'll have a formative Thursday in class. We'll review Friday in class. Your test will be the following Wednesday. Thanks for playing along.